we can use our knowledge of rectangular coordinates to define polar coordinates. So we start by creating a point in space that is expressed in both polar and rectangular coordinates. So this point in rectangular would be x comma y. This point in polar would be r comma theta. Now if I draw some of those values, the r and theta, so if I draw r and theta, I'm thinking about this radial line and this arc. So we have our r and our theta. And if we're thinking in rectangular, we have this length across the bottom, x, and this height across the side up here, y. And so together they form this right triangle. And so I can use things I know about that right triangle to get a relationship between r, theta, x, y, etc. So one of the first things that we can define is that this is going to form the Pythagorean theorem. So x squared plus y squared equals r squared. So x squared plus y squared equals r squared can be used if you have the x and y values to find the r values. That can be used when I convert between polar and rectangular. Okay. Another thing that I could use is so let's start labeling. If I have a rectangular and I want polar, so from rectangular to polar, this is one of the things I could use. If I take x squared plus y squared, I can solve for r squared. So if I just have x and y, how can I relate theta? So if I don't know r yet, if I just have x and y, I could use the tangent to find theta. So I could say that tangent of theta is equal to y over x, opposite over adjacent. And again, that would allow me to solve for theta. And so both of these two could be used to convert from, or you could also rewrite this as theta equals arctan of y over x, of course, as well. But they can be used to take things that are in rectangular and convert them into polar. Now, if I have the reverse, if I have polar, how would I go back and get rectangular? Okay, so if I have polar instead, something like a sine or a cosine value, where I want to take the two that I have, theta and r, and use them to find x and y would be useful. So for example, if I have sine of theta equals y over r, that would give me y equals r sine theta, and cosine of theta equals x over r, so that would give me x equals r cosine theta. Okay. So these two can be used if I want to convert polar into rectangular. So if I already have r and theta, I can find the x and the y. Okay. So if I want to go from rectangular to polar, I can use the Pythagorean theorem or tangent maybe, and if I want to go from polar to rectangular, sine and cosine along with the r value can allow me to find and solve for those. So based on our work above, let's convert each of these into polar coordinates. So they're rectangular right now, I want to convert them into polar. Okay. So 3, 3. So the first thing we want to do is find r. So we have 3 squared plus 3 squared equals r squared. So that's 9 plus 9, so that's 18 equals r squared. So I'm going to do square root of 18, and square root of 18 is 3 square root of 2 equals r. Okay. Now, r can be positive or negative, so you may want to think about that right now, thinking about the positive or the negative option. Depending on what we choose for our angle, r could be positive or negative. So let's start with the positive. It's very important to know what quadrant we're in. So we're in 3, 3 is in quadrant 1. And so if I use a angle in quadrant 1, I'll be able to get the positive r. So let's find the angle, and then we'll write down the ordered pairs for this one. So I know that tangent of my angle is equal to 3 over 3, so that's 1. So we need an angle whose tangent is 1. And based on the unit circle, that's going to have to be pi fourths, or 45 degrees if you like degrees. Okay. So our angle, or I'm sorry, our point 3, 3 is the same as the point 3 square root of 2 comma pi fourths. But that's not the only point that I could use, since polar coordinates are not unique. This is probably the primary point because it has the smallest angle with a positive side. But I also could, if I wanted to use an angle that was in quadrant 3 and a negative side, I could say negative 3 square root of 2 comma pi fourths. That would be 5 pi fourths. And pi fourths past pi. So that's the same point. But again, like if we start making them more complicated, we can kind of argue that the first one's the most simplified we could get right there. So we would say that's the primary ordered pair, although there are infinitely many possibilities, because we could just spin around to get to that angle multiple times, etc. So the first one is the primary choice right here. It's probably the most simple representation of this point that we could get to. Okay, so there are many. Okay, let's look at the next one. Okay, so again, I'm in rectangular, so I want to get into polar. So we'll take 2 square root of 3 squared plus negative 2 squared equals r squared. So that is, let's see, 9 times 4 is, I'm sorry, that's actually 3 when I square it, times 4 is 12. And then plus 4 equals r squared, so that's 16. So if I square it both sides, I'm going to get an r value of 4. And then tangent of theta is equal to negative 2 over 2 square root of 3. So that's negative 1 over the square root of 3. And if I look up which one that is, okay, so we have a square root of 3. So we're looking at either it's a negative, so we're looking at something that's going to be in quadrant 2 or quadrant 3, and so it's going to be either the 2 pi thirds or the 5 pi sixths, and so I need to figure out which of those two I want on top. And so for my tangent, I need the negative 1/2, or the 1/2 on top, and the negative square root of 3 over 2 on bottom. So if we just double check that, if we took 1/2 on top and negative square root of 3 over 2 on bottom, that gives us 1/2 times 2 over the square root of 3 negative, which is negative 1 over the square root of 3. And so, by the way, this is actually supposed to be quadrant 2 or quadrant 4, not 3. I think I mistakenly said 3. So it's either this point or this point, the one that had this point or this point. And so normally arctangent puts out a negative angle, so we're going to go with negative pi sixths. So let's go with the angle negative pi sixths as our theta value. Now, that may affect whether or not our r is positive or negative, so we have to go make sure we know what quadrant we're in. So we'll put our positive and negative back up here. Let's figure out what quadrant this point is in. So the original point has a positive x and a negative y, so it should be in quadrant 4. And so that's going to support the angle that we've chosen here. Had I used an angle that was in quadrant 2, we could have just done the same thing, but had a negative side. So we'll go ahead and write them both in for this one as well. So this one would be 4 comma negative pi sixths. Or we could have done negative 4 comma, and the angle in the other quadrant would have been 5 pi sixths. Okay, so again, 2 different ways of representing the angle, and since one of them is a negative, there's not necessarily a primary representation. I'm going to say the primary representation is probably the top one with the negative pi sixth, because that is what comes out of the arctan function. It's in the range of the arctan function. So that's what I would say. They're both valid. Okay, so there's 2 different ways to represent those 2 angles, both in polar. Both those 2 points, I meant to say, both in polar. Now, when we convert from polar into rectangular, these are going to be unique because there's only one way to write a point in rectangular. The x and y coordinates are unique. So let's take a look at these. So we have some r value and some theta value. And so if we do x first, the x coordinate is going to be the r10 times the cosine of pi thirds. And so I know the cosine of pi thirds is 1/2 on the unit circle. So that's 10 times 1/2, or 5. And I know the y value is 10 times sine pi thirds. And from the unit circle, that's 10 times the square root of 3 over 2. So I know that that's going to reduce to 5 square root of 3. So I get from my answer here that our rectangular ordered pair for this is going to be the ordered pair 5, 5 square root of 3. Okay. All right, and then this last one was in degrees, similar. So if I start off with x equals r, so -5 times the cosine of 135 degrees. Okay, 135 degrees is on the unit circle, so we can find that, and it's going to give us a negative square root of 2 over 2 for its cosine and a positive square root of 2 over 2 for its sine. So this is going to be -5 times negative square root of 2 over 2. So the ordered pair is 5 square root of 2 over 2 for the x coordinate, and for the y coordinate, -5 times the sine of 135 degrees. That's -5 times a positive square root of 2 over 2. So a -5 square root of 2 over 2. And so this ordered pair in rectangular is 5 square root of 2 over 2, comma, -5 square root of 2 over 2. Okay, and so if I think about where that angle is, 135 degrees is over here, but a -5, so it's actually in quadrant 4, and so is this, right? Positive x, negative y, so it's in quadrant 4 somewhere. Okay. Now, what we're thinking about these, couple of things that come to mind is, first of all, some points are easier to represent in polar than they are in rectangular. Like this point, it used nice little integer values, beautiful in polar, not so beautiful in rectangular. Same thing is true in reverse up here. 3, 3, very easy to write that in rectangular, but not as pretty looking when I write it in polar. So there are some where one system is more convenient than the other to locate the point. Okay, now there's a note about calculators. I can find mine. Let me pause for a second. Okay, so in my calculator, if I go into the angle menu where we've done the degrees and minutes before, there is this R, PR, so that's a rectangular to polar conversion to find R. So if I try this one, I have rectangular, so I'm going to put in 3, 3, and it's going to find me the R value, and so the R value that we got out for this point, 3 square root of 2, let's see if they're the same. So 3 square root of 2, it gives me the decimal value for 3 square root of 2. It didn't give it to me exactly, but it can help me a little bit. And so the same thing for the angle. I think I'm in degrees right now still, so it should give me the degree measure. So R to polar, so it's converting rectangular to polar, and I want to give me the angle, again from 3, 3 being the point. And so it gives me 45, because my calculator is in degree mode, and 45 is the degree measure for pi fourths. So I get the angle back out for pi fourths. I can do something similar over here. If I go into angle, and I choose P to R, so convert polar to rectangular, find X. Polar to rectangular, find X. So this is 10. Let me change my mode real quick to radians. Oops, wrong button. No. Okay, so I'm in radians now, and so I have 10 comma pi thirds, and we get 5 for our x coordinate, and so we can do it again. Polar to rectangular, find the y. 10 comma pi thirds, forgot the comma. And this one's going to give me, that is hopefully the decimal for 5 times the square root of 3. And it is. Okay, so it's not giving me the exact values, it's not capable of that, but it does give me a way of getting these there if I want to. So interesting. but it's not difficult to convert them using these formulas as well.